Hello and welcome to Amazon OpenSearch YouTube channel. My name is Himanshu Dikshit and I am a cloud infrastructure architect here at professional services team at Amazon Web Services. In today's video, we'll be talking about setting up Amazon OpenSearch ingestion pipeline to ingest logs of applications hosted on Amazon EKS using OpenTelemetry collector into Amazon OpenSearch domain, which can be used to set up observability platforms on top of it. There are several ways via which we can ingest application logs of containers running on Amazon EKS into Amazon OpenSearch domain or serverless collection, including pushing the logs directly. However, this architecture of using OpenTelemetry collector with Amazon ingestion pipeline to ingest logs into Amazon OpenSearch domain or serverless collection gives significant advantages over other methods. These advantages include data processing capabilities like filtering the unwanted logs, enriching the logs with additional metadata, or transforming the format of the logs, reliability and resilience, which includes local buffering, retry and backoff mechanism, resource optimization, which includes reducing the network calls as the writes to the domain are batched, operational benefits like single collection point, and security advantage of using managed service of IAM for authentication and authorization, and TLS SSL termination. These are few of the many benefits of using this architecture. In this demo, we will be deploying the architecture you see on screen. First, we will create an IAM role which the Amazon OpenSearch ingestion pipeline will use to ingest the logs into Amazon OpenSearch domain. Then we will be deploying a sample Nginx application along with OpenTelemetry collector agents as containers on Amazon EKS. We will then update the OpenTelemetry config to point to Amazon OpenSearch pipeline to complete the flow. So let's get started. To follow along, you need to have these resources already available in your AWS account. First, you need to have an Amazon EKS cluster up and running. You need to have either an Amazon OpenSearch domain or an Amazon OpenSearch serverless collection available. There should be network connectivity set up between Amazon EKS cluster and Amazon OpenSearch domain. You should have the ability to deploy the sample applications into Amazon EKS cluster. With that in mind, let's jump onto the console. Once you log in into your AWS account, you need to go to the roles section of the IAM. Over here, we will create a role for OpenSearch ingestion pipeline to use to give it access to Amazon OpenSearch domain. We will select AWS service as the trusted entity type and OpenSearch ingestion pipeline as the service. For the purpose of this video, we will be using AWS managed policy of Amazon OpenSearch service full access to give this role access to OpenSearch. We will give a name to this role and then create a role. Once the role has been created, we need to copy the ARN of this role and create a user mapping inside the domain itself. We already have an Amazon OpenSearch domain set up as part of the prerequisites we discussed earlier. We need to log into the dashboard. Once you log in into the dashboard, under the management section, click on security, and over there we will click on roles. We will give all access to this IAM role. Once you click on all access, click on mapped users, click on manage mappings, and then paste the ARN we just copied. We are giving the admin access to this IAM role onto this domain and click on map. This will give complete access to this IAM role to read, write, delete, and create indexes into this domain. Once the IAM role has been created, we will now create a pipeline which will use this IAM role to write into the Amazon OpenSearch domain we already have set up. To create the pipeline, we'll go to the Amazon OpenSearch service and in the left-hand menu under ingestion, click on pipelines. We'll then click on create pipelines. A number of ingestion pipeline blueprints should come up on the screen. For this demo, we will be using OpenTelemetry logs blueprint. Select the blueprint. For the path, we are going to use /v1/logs. There are a couple of network options available. It is recommended to deploy the pipeline using the VPC access. However, for this demo, we'll be creating a public access OpenSearch ingestion pipeline. You can add processors to filter out the logs, enrich the logs, or transform the format. However, we will be not adding any processors as part of this demo. Next, you can configure the sink where this OpenSearch ingestion pipeline will write. We will select the Amazon OpenSearch domain which we created for the purpose of this video. You can give the name of the index where this pipeline will write into. You have an option to either select the dynamic mapping or use a custom mapping. For this video, we will be using dynamic mapping. You can leave the configure pipeline options as is and just give the name of this pipeline. In the pipeline role, we will use the role which we just created and then click on create pipeline. Because the creation of the pipeline takes some time, I have already created the pipeline for this video. Your pipeline configuration should look something like this, where this is the endpoint of the Amazon OpenSearch domain which we have created. It is going to use this role which will give it access to write into the Amazon OpenSearch domain, and this is the index into which it will write. We have the bottom part of the architecture diagram available now. We just created the IAM role, which the OpenSearch ingestion pipeline we just created will be using to ingest logs into Amazon OpenSearch domain, which was created as part of the prerequisite which we discussed before. Now we will be using the Amazon EKS cluster, which was also created as part of the prerequisite, to deploy the sample Nginx app and also the OpenTelemetry collector agent as containers. We also need to create one IAM role which the containers will use as a service account, which gives them permissions to use the OpenSearch ingestion pipeline to complete the flow of logs. I'll be using Visual Studio to deploy these containers. So let's hop on to the Visual Studio and then verify the same onto the console. So I have this script which I created to deploy the remaining components of our architecture. We'll go step by step and go through each of these files to understand what they are doing. So the first step we do is to create the IAM role which the containers will be using to push the application logs into the OpenSearch ingestion pipeline. Next, once the IAM role is created, we'll be creating a config map Kubernetes object which will contain the config for the OpenTelemetry collector agent, and essentially it will basically tell them which logs to watch out for, basically send them to OpenTelemetry OpenSearch ingestion pipeline, and what is the endpoint of the OpenSearch ingestion pipeline where it will be sending to. So that will be created as part of the config map. Next, we'll create a service account using the IAM role which we create in step 1, which will be used by the containers which we'll be deploying in next steps, which gives those containers permissions to use the OpenSearch ingestion pipeline. Next, we will create the containers using the Nginx sample app and the OpenTelemetry agent. We'll be using the publicly available image for Nginx and OpenTelemetry. Once the containers are deployed, we'll be creating a service on top of the Nginx app. We'll be creating a load balancer type in front of the Nginx application, and we'll be using the endpoint of that load balancer to test out the application and generate some logs, which will be then finally pushed via OpenTelemetry collector and OpenSearch ingestion pipeline into Amazon OpenSearch domain. So let's get started with step 1, which is the IAM role. So IAM role, as you remember, when we created for OpenSearch ingestion pipeline, has 2 components. One is the policy, which will give it the permissions it needs. So for this, we have the OpenTelemetry just needs permissions to ingest the logs it will be monitoring for the Nginx app into the OpenSearch ingestion pipeline. So we just give one action, which is OSIS ingest, And for the resource, we are giving the ARN of the OpenSearch ingestion pipeline we just created. So for that, you can go to the OpenSearch ingestion pipeline which you created, and you should see it over there. And we also need to add a trust policy, because this is going to be a service account which will be used by Amazon EKS cluster pods. It has to have the OIDC provider as the trusted entity, because we are using IRSA, IAM role for service account. So every EKS cluster has a different OIDC provider. This is for me. You can update your trust policy on the similar lines using your OIDC provider. Once this is done, the script is essentially using these two files and creating the IAM role. Next, we are going to see what we do for the config map. In the config map, this is the config map we have for the OpenTelemetry collector agent. We'll be using a config map kind. This is the name of the config which will be used by the OpenTelemetry agent containers, which we'll see later. And we are deploying it in the namespace default for now. So these are the four more sections. What is the extensions it is using for authentication? We are using SigV4 auth. What is the region and the service? OSIS represents OpenSearch ingestion service. The receiver basically tells what file which we are going to send it to OpenSearch, Amazon OpenSearch domain. So the Nginx app will create this file. So we are going to anybody accessing the Nginx application. Every time someone accesses, a log record is generated. So we'll be using this for our testing purposes. It can be any of your logs generated for your application. In our case, we are using that. Then we are saying that we start at the beginning. As soon as the first entry into the log file comes in, that has to be pushed into the OpenSearch ingestion pipeline. As I said before, we have the option of adding more processors and operators in the OpenSearch ingestion pipeline, but we can do it at the OpenTelemetry collector level as well. So this is just to showcase that capability. We are using one of the fields, using some regex and adding a couple of fields, including the severity. Based on the severity, whether it's an informational log or it's a warning or an error, and then also adding the name of the service and the log type as an additional metadata field. We are also adding processors to batch the number of records being written into the OpenSearch ingestion pipeline instead of writing it as soon as the record comes, hence reducing the load on the network. We are also adding a couple of more metadata fields, which tells us which Amazon EKS cluster it is coming for. For me, this is the cluster which I have created, and what is the application this log belongs to. Obviously, this can be updated based on the requirement of the team. Next, the exporter tells where to export these records to. So we are going to export to OpenSearch ingestion pipeline. So that's why the endpoint of the OpenSearch ingestion has to be placed over here. And then at the end, we have added /v1/logs. So if you remember, when we were creating the OpenSearch ingestion pipeline, we had selected the path where the OpenSearch ingestion pipeline will look for the log records, and that was /v1/logs. So we add that over here. So when the logs are exported, they will be written as /v1/logs for this OpenSearch ingestion pipeline endpoint. We are using SigV4 auth, which basically tells us to use the IAM role via the service account, which will be deployed as part of the containers. So it will use the temporary credentials to authenticate with the OpenSearch ingestion pipeline. And the last part is it tells what all extensions and what are other components like the receivers, processors, and exporters which have been created will be used in this config. So if you see, the processors are batch and resource, the receiver is the file log, and the extension is SigV4 auth. So we are just putting that over here so that the OpenTelemetry agent knows what components to use. Once the config is created, we then create the service account using the IAM role, which we had in step 1. So this is the simple YAML file which we'll be using to create the service account object using the ARN of the IAM role we have. Once the service account is created, we will then create the deployment, which will deploy the Nginx app and the OpenTelemetry collector agents. So it has two containers as part of it. We have our OpenTelemetry demo app, which basically uses the Nginx image. And then we have passed an argument, which basically when we curl to this Nginx app service, it will give us some default output. It will be running at port 80, and then it is adding the service account we created. And then we also have the OpenTelemetry collector container over here, and it is using the OpenTelemetry public image. It will also use the config map we just created, which will be stored in this path. So the config map which we created in the previous step will be used by this collector agent, will basically help it to understand what is the file it needs to monitor, where to export, what is the IAM role it needs to use to give it permission to write into the OpenSearch ingestion pipeline. So these are the two containers it will be using to deploy into the Amazon EKS cluster. And then the last step will be to create a service in front of the Nginx app, the hotel demo app, which we created. The type will be load balancer. So it will create a Kubernetes load balancer object, which will give us an endpoint, and then we will be using it to curl to the load balancer so that it will generate some logs. One more thing I just wanted to mention, as part of the basic config we pass to the Nginx container, we are doing while loop, which generates logs every 6 hours automatically. So it will basically going to curl against the local host, that is the container itself, and generate the log. And that log entry will go into the var log nginx access.log, which will be used to push into the Amazon OpenSearch domain. So basically, even if we don't do a curl, some logs will be generated, which we will see when we finish this deployment. So with that in mind, let's execute this deployment script and get all the components created, and then we can test out if everything is going fine. We'll log into the Amazon OpenSearch domain and see if the log index is being created and we have some logs entry or not. Let's run the script. So first it is using creating the IAM role, then config map, deployment, service account, and everything has been created. We can run the kubectl command to see if the pods are up and running, and we have the load balancer also created in front. So we have two Nginx containers we can see already up and running, and we have the load balancer in front of it. Now let's do curl to the load balancer endpoint. This will generate some entries in the log files which we are monitoring, and the pipeline should then ingest those log entries into the Amazon OpenSearch domain. If we curl to some other path in this endpoint, say /test, because the page is not configured, it should give a 404. So we should see few entries in the Amazon OpenSearch domain. So now let's log into the dashboard of the Amazon OpenSearch domain and see if the index is created and we see any entries in the Amazon OpenSearch domain. So we are in the dashboard of the Amazon OpenSearch domain we had created, and we had configured the OpenTelemetry agent and the OpenSearch ingestion pipeline to ingest the logs we got from the sample Nginx application we deployed in the Amazon EKS cluster into this domain. So once you are in the dashboard, we can go into query workbench, and we should see the log which we had mentioned in the configuration of OpenSearch ingestion pipeline, which is hotel test logs. We can do a select against this log to see if we get the logs from the Nginx application coming over here. We do a run, and then we see the entries over here. There are entries, the severity which we had added as part of the hotel operation to add metadata based on the error code or we got from the application is over here. So the 200 means when we did a curl against the load balancer endpoint, which was available, the root path, but the path where it was not available /test, we were getting 404. Even that entry we can see over here. And if you see we just did couple of curls, but we see multiple entries. It's because of the while loop we had configured, and within the loop we had 3 to 4 curls at the correct and the wrong path against the load balancer. So that is why we see multiple entries. Congratulations, you have now deployed a solution to ingest application logs into Amazon OpenSearch domain using OpenTelemetry collector and Amazon OpenSearch ingestion pipeline. Using OpenTelemetry collector with OpenSearch ingestion pipeline provides 2 layers of data processing. Collector handles buffering, retries, and initial transformation, while ingestion pipelines enables advanced log processing like field extraction, enrichment, and filtering before finally storing the logs into Amazon OpenSearch domain. This architecture improves reliability through buffering and retry mechanism at collector level while reducing OpenSearch domain load by pre-processing data through OpenSearch ingestion pipeline, ultimately providing better control over log processing, cost optimization, and improved search capabilities. Having applications store the logs in Amazon OpenSearch domain enables powerful log analysis through full-text search, real-time visualization, alerting, and anomaly detection capabilities, while providing security analysis and performance monitoring tools. The service allows business to derive actionable insights from their logs using dashboards, ML-based analysis, and integrated monitoring solution. Thank you for joining us today. If you are building a log analysis solution using Amazon OpenSearch, we would love to hear about your experience in comments below.